Hey everybody, this is Mr. Munson, and we're in Unit 6. We're talking about similar figures, of course. This particular section is called Similar Figures 6.2. Definition of similar figures is this. Two figures are similar if and only if every angle in one of the figures has a corresponding congruent angle in the other figure, and all the sides are proportional. What that means is when I write a ratio between the two corresponding sides, that ratio has to equal the same ratio as all the other corresponding sides. Let's take a look at a problem real quick and just touch on it. So before we go too far, we need to remember we have vocabulary for this unit. If you skip 6.1, we did all of our vocabulary for Unit 6 in that video. So you need to put me on pause if you miss 6.1, go back to that and copy down all the vocabulary words. So take a look at these two figures. If I wanted to see if they were similar, according to the definition, for every angle, there has to be a corresponding angle that is congruent to it. Okay? All right, so far we're doing so good. This is looking good. All right, that pretty much checks to make sure that the angles are all matching up and that they're congruent. Now the sides. The sides are going to be a little bit more involved. So we said earlier that the sides have to be proportionate. What that means is that when I grab a side and its corresponding side, I can write a ratio between them. For them to be proportional, and again, back to the definition of proportion, when I say the word proportional, you should be thinking a ratio equals a ratio. So what I'm going to do is I'm going to match that up to another set of sides. And then I can do that with another set of sides. And then the last set of sides. And I just realized that this side and this side don't have a number on it, and they should. We have to check all the sides. So I apologize for that failure in this drawing. But what we're going to do is we're going to compare all these ratios and make sure that they're equal. If they are, then we say the sides are proportional. So let me reduce these fractions. All right, and look at those fractions. They all reduce down to 1/2 or 0.5. If any one of them turned out to be a different number, then these two figures are not similar. All it takes is one ratio not to equal all the others, and the two figures are not similar. So let's take a look at a couple of these. When we take and look at all the angles and all the sides and compare them, that's proven that the figures are similar by brute force. So let's put this kind of in a more formal way. It says I can determine if polygons are similar using definition of similarity. That means I have to show all the angles are matched up and all the sides create a proportion or create ratios that are proportional. And I can write a similarity statement given a diagram. I'm going to give the letters to these figures real quick, the corners. Go ahead and copy down that figure. All right, let's do this by brute force. So now I'm just going to list the angles and its corresponding angles and confirm that they're equal. Okay, the first step is I've confirmed that all the angles in the left figure correspond to a congruent angle in the right-hand figure. The next thing is to show that the sides are proportional. So I write all the ratios and set them equal. Now I'm going to confirm them. Now we did this in the slide before, so we know that these are. And again, I'm stating that I made a mistake. I didn't have the unit measurements for that missing side. And every side has to have a side so you can compare the ratio. And just one of the ratios can throw out the whole figure as being similar. Okay? So we know from the previous slide that this is 1/2 and so on. Okay, so now I've done this. I proved that for every angle, there's a congruent angle that corresponds to it. For every side, I can write a ratio between its a side and a corresponding side, and that ratio equals all the other ratios. And so that, by brute force, shows me that the two figures are similar. If this had 30 sides, I'd have to show 30 angles and then 30 ratios. Okay? That's why it's called brute force. All right, so now the figures are similar. Let's write a similarity statement. All right, there I have it. Now, since this is an irregular figure, I would normally write, triangle ABC is similar to triangle blah blah, or I could draw this boot-looking shape in front. But in this case, I'm just going to write the three letters FIG stand for the figure. So figure ABCDE. Notice that those are in alphabetical order. Is similar to the other things that go along with it, K, L, M, and J. And I just used my angle similarity column to help me match things up correctly, okay? So the left side has to be in alphabetical order for my class. The right side just needs to match up, okay? So sometimes they'll be in alphabetical order and sometimes they won't. Let's move on. Okay, see if you can show by brute force if these two triangles are similar. Put me on pause and then come back and check with me. Okay, so I first of all went off and tried to find the missing angles, because when I have a triangle or any figure like this, if I have a missing angle, I'm going to do everything I can to find it. Now, if you happen to be given a problem like this where the vertices, the corners of the triangles are not given, then you make your own up, okay? So I'm going to create some new ones. Now I'm going to go through and list my angles as being congruent. Now I'm going to compare the sides, make sure that the ratios are proportionate. There's that, and let's write a similarity statement. So since the angles are congruent, they have corresponding congruent angles, and the sides are all proportionate, I now can write a similarity statement. If one of those fractions or one of those angles didn't match up, then the thing cannot be written as similar, and we would say these two figures are not similar. Let's write a similarity statement. Okay, so I broke my rule there. The left side is not in alphabetical order, but the reason is because it spelled a cool word, cat. And so it would have been great if the other side spelled out dog, but it doesn't. So here we go. All right, go ahead and work on this one. Show by brute force that they're similar. And if for some reason they're not, then you would state that they're not similar. And then write a congruent statement. Sorry, not a congruent statement, but a similarity statement. Of course, you're putting me on pause and doing the work right now on your own. Okay, so I'll reduce these fractions with my calculator to see if they're the same. But be careful when you're grabbing these. Make sure that whatever triangle or whatever shape you grab from on top on the first one matches you're grabbing it from the other one on the top of the other ratios, okay? Sometimes students will grab and start flipping these things around, and that will definitely create a problem with your answer. Okay, so hopefully you recognized that these two shapes are not similar because it failed in the sides being proportionate. Okay, so these two right here are not equal. I could stop at that point. I really don't need to follow up with finding any others. Once I have two that don't match up, I'm done, and these two figures are not similar. All right, let's go on. All right, to find the scale factor is very easy. All I got to do is write a ratio between any two corresponding sides. All right, let's start off with the information that the two triangles are similar. I need to tell you that. So just grab any two sides and it gives me a scale factor. Now, a lot of times the problem will be given to you and say, write the scale factor between these two triangles, or it'll say, write the scale factor between 1 and 2. And there's kind of an order that's given when it's given that. Sometimes it's just a left to right kind of scale factor, so we'll put that one on top and then the other one on the bottom. There should be some kind of indication to tell you how to write the scale factor, be it which number goes on top, which number goes on the bottom. If it says, hey, this is a reduction, then we need to make sure that it makes sense that the scale factor would be a reducing factor. Like if this turns out to be 1/2, then that's a reducing, something's 1/2. Let's take a look at writing a scale factor for this. And I've corrected over on my right-hand side. I had a C there instead of an E. I apologize for any confusion that brought you. So anyway, I did not take the 35 and 14 and put it together because they're sitting in their same position. I looked at the similarity statement and made sure things matched up. So I can see that AB matches EF, and so I took those two particular numbers, and I'm not going to fall for the trap that they're just sitting in the same position. I'm going to make sure the similarity statement tells me which sides go together. So I'm going to write that ratio, and that's the scale factor. Now, we usually reduce these scale factors. In this one particular ratio reduces down to 5/2. Okay, go ahead and write the scale factor for this problem on your own. Put me on pause and come back. So I wasn't given a similarity statement here. So if I was just stuck with that, I would go with, hey, these figures have two sides, that 30 and that 30, that are congruent. So I think it matches up to the 18 and 18. So I wrote a scale factor, 30 is to 18, and then reduced it to 5/3. Scale factor, very easy. All right, so here I have two figures, and I have an x in the problem. As soon as I see an x, I know I'm going to be writing an equation. In this section, similar figures, proportions is the master equation that we're using. So let's look at writing an equation. Now, typically in a figure like this, we'd be told that the figures are similar, and then they'd give us some letters so we can match up the sides for sure. This is a pretty easy matchup. The figure is kind of irregular. It's kind of like a triangle with a dent in it. And I'm pretty sure that x minus 2 corresponds to the 12. So now what I need to do is write a proportion. Let's just start by writing that ratio. Okay, so that ratio has to equal a ratio between any two other corresponding sides. I could choose that set of corresponding sides. Or I could use 27/36. I'm going to end up with the exact same answer, I have to tell you. Now, 36 over here doesn't have a matching side, so I'll stay away from that set. Let's go ahead and solve that and find out what the missing x is. All right, pretty easy. I found that x was equal to 10 using a little bit of my cross multiplication stuff. Hey, what about if I was to ask you what this side would be equal to? If I didn't put a y there or whatever, I just say, I wonder what, it started the problem off with, I wonder what that side would be. What you would need to do is understand that I can take that 36 and find that missing side by simply taking any two other sides and creating the y. It doesn't matter. Okay? So I'm just going to do a setup for that and then not even solve for it. We could do that some other. And there you have it. So I could go and find out what that missing side is as well. All right, let's move on. Okay, try your hand at doing this problem. Let's find out what x is. Put me on pause. Okay, there we have x equals 7. Hey, suppose I asked you to find the perimeter of the shape on the left-hand side. So I need to go find those other sides as well. I take the x and I can plug it in to find that side, but I'd need to find the 35s, the sides that match up with the 35. So of course, when I find one of them, I found the other. Let's do that real quick. Put me on pause and go find what the missing sides are plus the perimeter of both of them. So I found the perimeters just by simply adding up the sides, and I found that the missing side there was for k was 14. If I wanted to know what the perimeter ratios were, I'd just take the perimeter ratios and write them. Okay, so this reduces down to 5/2. Okay, now here's a really important point. I want you to write this down in your notes. This 5/2 matches this ratio right here and any other ratio between the corresponding sides. Matter of fact, the perimeter ratio matches the scale factor and any corresponding sides. Okay, let's write that down in our notes real quick. Put that someplace where you're not going to forget it. Okay. All right. So before we go on to the next slide, I want to tell you that the next slide is the try-it problems. After you get the try-it problems done, make sure you come back and watch the rest of the video. There's another bonus problem at the very end of the video. There's two bonus problems. One's going to be on your try-it problems, and then there's going to be another bonus problem that I'm going to disclose to you at the very end of the video, where you can get a few more points than the typical bonus that's available on the try-it problems. Okay? So go look at the try-it problems, get that done, but don't forget to come back and watch the rest of the video. Take care, everybody. All right, there's your, whoops, let's get that to full screen. All right, everybody, there's your try it problems. Have at it. Have fun. There's a bonus problem at the bottom. And if you watch the video, there's a secret about the try it problem system.